Hello, everybody. So, today we are going to discuss a question from some sort of Math Olympiad PYQ. It was sent to me on my Gmail account, right? It was mailed to me. So, I'm not really sure about the origin of this question. This was all that was mentioned in the email. I'll leave my email in the description so that you can send your queries out as well. Now, first of all, I would like for all of you to try this question first. Like, pause the video, try it, try to think of an approach, take 5 to 10 minutes, like just brainstorm this, and then we'll continue with the solution. So, I'm hoping all of you had paused it and tried. So, all right. So, it is given to us that there exists a polynomial f of x, right? It can be given by the expression, right? It can be given by the expression. And then there's gx raised to some other power. Let's just use something. Oh, we don't really know what power. Let's just use a. Okay. So we need to figure out the polynomials for which x minus c is surely a factor. So it is not really easy to see, but if we were to derivate it, if we were to derivate this function, then we would get z x minus c z minus 1 gx. I'm just not writing the parentheses for gx right now. And then we'll get x minus c z and then we'll get gx's derivative, right? This is what we'll get. Now we can clearly see that we can take this term as common, and we can write the expression as something like this one, and then there's parentheses and all the terms come right here. Okay, so for example here it would be something like this x minus c gx. It would be something like this, but we don't really care about that. All we really care about is this z right here. So following this pattern, next time what would happen is it would become a factor of x minus c z minus 2. So we can notice that the amount of derivatives, the order of derivatives is equal to what is getting subtracted from it, right? We can clearly see that. So now what we must do as the next step is we keep derivating it and we observe this pattern throughout and throughout, right? We notice that when we derivate it z amount of times, it is not going to be a factor anymore, because x minus c z minus z will be 0 and it will become 1. So it will only be a factor until z minus 1th derivative, right? It will only be a factor until this term. So the total polynomials it is a factor of can be given by z minus 1 derivatives, all these derivatives plus 1 because the polynomial itself. So it would be z. But in the question it was asked that how many other polynomials is x minus c surely a factor of? Other. You need to pay some attention to it. So the answer is going to be z minus 1 then. Let's check. Okay. So this is going to be the answer. This is not something that you can easily see. It basically covers a concept which is taught for Olympiad classes, which is known as repeated roots. So the concept was this only, like when you derivate repeated roots, they will be a factor of if, for example, x minus a of order m is a factor of fx, then they will be a factor until the m minus 1th derivative, right? They will be a factor until this term. So total polynomials, they are a factor of our m, and other than fx is m minus 1. This is all it is taught in repeated roots, and we just study this concept which is very vital for JEE Advanced or Olympiads via this beautiful example. Well, if you have any other doubts, we can discuss them sometime later. Just make sure that you subscribe to the channel, like the video, and send your doubts on the email account mentioned below. Thank you.